Welcome to SSR Pharma Media, your trusted source for pharma knowledge. Pharmaceutical Inorganic Chemistry. In that, today we are going to discuss about gastrointestinal agent. So, PIC MCQ series, your exam power boost. Prepare, practice, succeed. So, in the gastrointestinal agents, today we are going to discuss about gastrointestinal agents. In that, acidifiers, antacids, and agents promote bowel movements. So these are all the three topics present under the gastrointestinal agents. So acidified, these are all the examples of the compounds under each category. So acidifier, these are all the example, and antacids, we are going to discuss about ideal properties of antacid, combination of antacids, and these are the examples of the compounds of antacids. And agent promotes bowel syndromes. So these are all the examples of the compounds. Now we are going to discuss about these concepts. So acidifier, first we will discuss about the acidifier. So acidifiers are agents that increase gastric acidity by supplying or stimulating the secretion of hydrochloric acid. So examples, sodium acid phosphate, dilute hydrochloric acid, and ammonium chloride. So these three are the examples for acidifier. So, and in that acidifiers, so mainly sodium acid phosphate, it is also sodium dihydrogen phosphate and dilute hydrochloric acid. So other name of this sodium phosphates are sodium phosphate, sodium dihydrogen phosphate, and sodium orthophosphate. So dilute hydrochloric acids. So these are all introduction about these two acidifiers are, it is systemic acidifier. So sodium acid phosphate is used as a systemic acidifier, used to acidify urine and maintain acidic pH. And hydrochloric acids are strong, diluted strong HCl, used as a gastric supplement. So there is the difference. So dilute hydrochloric acids are used as a gastric supplement. It is used for the digestion, and the sodium acid phosphate is a systemic acidifier. Whenever blood become alkaline, so in order to neutralize the alkalinity, so this sodium acid phosphates are used as a systemic acidifier. And general method of preparations and other properties and assay methods and main uses of these compounds, you read it by taking the screenshot. So, and mainly these acidifier and finally uses, medicinal uses. So sodium acid phosphate is used as acidifier and prevents the calcium phosphate renal stones and used in electrolyte replacement therapy also. But in the hydrochloric acid is used as a treatment of achlorhydria and hypochlorhydria. It is used in acidifying mixtures. So the achlorhydria means achlorhydria, hypochlorhydria, both are same meaning. So that means it's a decreased hydrochloric acid content in stomach. So it is called achlorhydria or hypochlorhydria. So whenever the hydrochloric acid is decreased in stomach, so in that case we will get the digestion problem. So the enzymes may not work. So for that reasons, this dilute hydrochloric acids are used as a mixtures in order to increases the HCl, so improving the enzymes actions in the stomach. We'll see the questions. Which of the following is not a synonym of sodium acid phosphate? So option D, not. The question is not a synonym of sodium acid phosphate. So option D is the answer. Disodium hydrogen phosphate. So disodium hydrogen phosphate, Na2HPO4. This is the molecular formula. But the sodium acid phosphate is dihydrogen phosphate. And remaining are all the three are, it is another name for sodium acid phosphate. Except option D. Sodium acid phosphate acts as a systemic acidifier mainly because it, so option B, releases hydrogen ion in stomach. In solution. Release hydrogen ion in solution so that it acts as a systemic acidifier. Sodium acid phosphate is act as a systemic acidifier because in solution it liberates the hydrogen ions. Sodium acid phosphate is commonly used for, so option B, prevent calcium phosphate and renal stones. Sodium acid phosphate is prepared by partial neutralization of phosphoric acid using, so option C, sodium carbonate or sodium hydroxide. Dilute hydrochloric acid is officially required to contain, so option B, 9.5 to 10.5 percentage of weight of hydrochloric acid. So this is called dilute hydrochloric acid. So the concentration is very important, 9.5 to 10.5 percentage weight. Dilute hydrochloric acid is primarily used in the treatment of, option B, achlorhydria. So it is a supplement gastric acid in conditions where stomach acid is absent or low. So next is we'll see about the ammonium chloride compound. So ammonium chloride also acts as a systemic acidifier and also it acts as a expectorant. So now role of ammonium chloride acts as a acidifier. Its role is, so it is in solution it liberates the hydrochloric acid. Sorry, chloride ion. It liberates the chloride ion in solution. So then ammonia is converted to urea in the liver and releasing hydrogen ions. So this released hydrogen contributes to systemic and urinary acidification. So it's a systemic acidifier. It is used for the urinary acidifications. So main thing is it liberates the chloride ions. So sorry, not chloride ion. H4 is releasing the hydrogen ion. Chloride ion, when solution liberate the chloride ion, and ammonium in liver it's release the hydrogen ion. Gastrointestinal agent. So mechanical use of ammonium chloride. So used as a systemic and urinary acidifier. It's a metabolic. It correct the metabolic alkalosis and it acidifies urine in UTI, urinary tract infection, and helps drug excretions. And expectorant is used in the cough syrup. It is remove the sputum from the lungs by irritating gastric mucosa, and it produce reflex stimulation of bronchial secretions, thereby thinning mucus occurs. And it's used as a diuretic. Diuretic means increasing the urine output, promote the diuresis by altering ionic balances. Which of the following act as a systemic acidifier? So option B. So ammonium, assay of ammonium chloride. So ammonium chloride when treated with water, it forms ammonium hydroxide and hydrochloric acid. So ammonium hydroxide, it containing the hydroxide ion, and we will take the burette solution as sodium hydroxide. The sodium hydroxide also it's containing hydroxide ion. So these two hydroxide ion there, so that may produce error titration results, burette report. So that in order to prevent this ammonium hydroxide interferences, we are treated with formaldehyde to form hexamide. So this hexamide does not volatilize. It will not escape, it will not produce the hydroxide ion during the titration. So that the liberated hydrochloric acid easily react with the sodium hydroxide and it produces sodium chloride salt and water. So this in this titration, phenolphthalein used as an indicator. Next, ammonium chloride, it told modified Oldgard's method. So modified Oldgard's method, it can be titrated with a back titration, and in the burette we used to take the so ammonium thiocyanate. It's ammonium thiocyanate in the burette. That means thiocyanate ion. The excess of silver nitrate treated with ammonium chloride to form ammonium chloride treated with silver nitrate to form silver chloride precipitate. So the remaining unreacted silver nitrate titrated with ammonium thiocyanate, it is there in the burette to form silver thiocyanate. And then after the endpoint, the ferric complex are used as an indicator. Ferric alum. This ferric alum react with the thiocyanate and to form ferric thiocyanate. This red complex. So endpoint produce the color changes red color. In the acid-base titration, assay of ammonium chloride formaldehyde is added to. So option B, convert ammonia to hexamide. In the assay of ammonium chloride, liberated HCl is titrated with. So option B, 0.1 in sodium hydroxide. Which indicator used in the modified Olgart's method? So option B, ferric alum. Phenolphthalein is used in the acid-base titration as an indicator. Modified Olgart's method is a type of, it's a back titration. Option C is the correct answer. Next is the ideal properties of antacid. So ideal properties of antacids. Antacids means so acid neutralizes the excess. Antacid neutralizes excess gastric acid and relieve hyperacidity related symptoms. And its the main ideal properties: rapid onset of action, and it has long duration of neutralization process. So non-systemic, it should not systemically it should not act. Antacid means, and it should not cause constipations or diarrhea, and should not produce systemic alkalosis, and it should be palatable, stable, and inexpensive. So this is the very important. They may ask for the 2 marks and 5 marks, even MCQs also. Ideal properties of antacids, and combination of antacids also very important. So it is used to balance the GI side effect, gastrointestinal side effect. Aluminum salt, suppose we are used alone, means it causes constipation. Magnesium salt, suppose we used alone means it produces diarrhea or laxative. And calcium causes hypercalcemia. So in order to, and sodium bicarbonate causes systemic alkalosis. And magnesium and aluminum salt, this use causes precipitation of phosphate in GIT tract. So in order to prevent these effects, so we are using this antacid in the combined to produce balanced GI effect. So for that reasons only we are going for the combination of antacids. So next is the, we'll see the types of antacids. So types of antacid. So systemic antacid, non-systemic antacid, calcium containing antacid, magnesium containing antacid, aluminum containing antacid, combination of antacid, and alginates. So these are all the types of antacids, and so there is the definitions and examples are given here. So read one by one, take a screenshot and read it. Which of the following is a systemic antacid? So option C, sodium bicarbonate. Which antacid is most commonly associated with constipation? So option B, aluminum hydroxide. Which of the following antacid act rapidly but may cause rebound acidity? So it is very important questions. Repeatedly they are asking in the various competitive exams. So option A, calcium carbonate. So calcium carbonate is provide fast and strong neutralizing but may provoke acid rebound due to stimulation of gastric release. So they are in the B.Pharm and Pharm.D, diploma and Pharm.D questions. The 2 mark questions they're asking. In the 2 mark questions they're asking what is rebound antacids. Give examples like that. The questions also they're asking repeatedly. So rebound and antacid means so due to stimulation of gastric release produce rebound antacid. So example, calcium carbonate it is act as the rebound, producing the rebound antacid. Which antacid is unsafe in renal failure due to risk of accumulation? So option D, magnesium hydroxide. So it is unsafe when those are having renal failure, that means kidney failure, because kidney cannot excrete magnesium. so leading to magnesium toxicity. So aluminum accumulate is also a concern, but magnesium poses a more immediate risk than aluminum. Why magnesium and aluminum antacids commonly used in combination? So option C, to balance the constipation and diarrhea side effect. Match the following antacid types versus major side effect. So option A is the answer. Aluminum salt is the constipation, magnesium salt is the diarrhea, and calcium salt is a hyperkalemia, and sodium bicarbonate is a systemic alkalosis. So next is the antacids examples: sodium bicarbonate, aluminum hydroxide gel, and calcium carbonate. So these are all the examples of antacid. So sodium bicarbonate, also called as baking soda. So these are a molecular formula for the each compounds. Next is we'll see antacid parameters: sodium bicarbonate, aluminum hydroxide gel, and calcium carbonate. So baking soda, already told synonym, and properties and all you read it. And assay, sodium bicarbonate is assayed by acid-base titration, and aluminum hydroxide gel is assayed by complexometry because aluminum metal ions are there. Calcium carbonate is also, it is assayed by complexometry because of the calcium metal ions is there. And medicinal uses also you read it is all mainly for antacids, and sodium and they act as a urinary alkalizers, electrolyte replenishers. So this aluminum hydroxide is used for the extra peptic ulcers, and calcium carbonate also calcium supplement and treat for osteoporosis and hypocalcemia. Osteoporosis means calcium supplement. It's used. It's mainly prescribed for the pregnancy women and those who are having the knee pain, hip pain. So calcium deficiency, those who are have, for such a patients is used as a calcium supplements. And test for purity is very important. For these three, generally antacid test for purity is acid neutralizing capacity. So antacid means we have to test its purity by using this method, acid neutralizing capacity. It's a very important MCQ. The compound commonly known as baking soda in pharmaceutical and household use is, so option B, sodium bicarbonate. Sodium bicarbonate neutralizes gastric acid by producing, so option C, sodium chloride and carbon dioxide. Which test for purity is specifically applied to aluminum hydroxide gel to ensure its therapeutic effectiveness as an antacid? So option B, antacid acid neutralizing capacity test. So this test procedures are, parameters are explained, you read it. Calcium carbonate acts primarily as, so option A, non-systemic antacid. It is not a systemic antacid. Precipitated calcium carbonate is commonly used as, option A, dentifrice. So the calcium carbonate mainly used as a dentifrice. Dentifrice means it is used for cleaning the teeth. Cleaning the teeth, it's used for the preparation of tooth powder and toothpaste as the main ingredients. Next is the agent promotes bowel movements. Gastrointestinal agents that promote bowel movements are known as laxative and cathartics. They help relieve constipation and prepare the bowel for diagnostic procedures to remove toxin from GI tract. And laxative also called cathartics. So our agent promotes bowel movements by softening the stool and increasing its bulk or stimulating its intestinal motility, thereby facilitating defecation. They are primarily used for the relief of constipation and bowel cleansing and to ease the passage of hard or dry stools. And these are all the examples of cathartic: magnesium hydroxide, megalrate, magnesium carbonate. Sorry. So these are all the examples of magnesium carbonate, magnesium sulfate, sodium orthophosphate, and sodium potassium tartrate. These are all the example for the um, cathartics. So molecular formula you read it and a synonym of the each compounds. So you read it carefully and very important here Roselle salt. It's a Roselle salt means sodium potassium tartrate. And in future you will study one more salt, Mayer salt. Mayer salt means it's a potassium sodium tartrate. So you will read future in forthcoming videos. But Roselle salt is the they are asking repeatedly Roselle salt and Mayer salt. Roselle salt means first sodium will come. Sodium potassium tartrate. Mayer salt means potassium sodium tartrate. That is the difference. So only the difference between the sodium and potassium position. So first sodium potassium tartrate means it's a Roselle salt. It's a very important MCQ's question. And the classes you read the magnesium hydroxide is a osmotic laxative. It's a megalrate antacid with mild laxative, antacid with mild laxative, magnesium carbonate, and magnesium sulfate is a saline cathartics, also osmotic purgative, and saline cathartic sodium orthophosphate is just a saline cathartic, and sodium potassium tartrate is used as a saline laxative and purgative, and retain it's a mechanism you read it retain water and increase peristalsis. So osmotic and saline cathartic both are working in the same principle. So increasing water content in the intestine, so thereby increasing the peristalsis and produce constipations. So saline cathartics also increasing the osmotic load of the intestine, so thereby rapid evacuation of bowel takes place, thereby bowel cleansing takes place. So milk of magnesia is the synonym of, so option B, magnesium hydroxide. It's very important question. Roselle salt refers to, so option C, sodium potassium tartrate. Which compound is also known as Epsom salt? So Epsom salt is, we know, magnesium sulfate. Phosphate of soda is the synonym of, so option C, sodium orthophosphate. Which has the synonym magnesite? So option B, magnesium carbonate. Magnesite is a magnesium carbonate. The molecular formula of Epsom salt is, so option B, magnesium sulfate, 7 water molecules. Magnesium hydroxide belongs to which class? So option B, osmotic laxative. Magnesium sulfate is classified as, so option C, saline cathartic. Megalrate is primarily classified as, so option A, antacid with mild laxative action. Megalrate causes mild laxation mainly due to, so option A, release of magnesium hydroxide. Megalrate is mainly used in, so option A, acid indigestion. So answer is option A, acid indigestion. Sodium orthophosphate is primarily used for, so option B, bowel cleansing before procedure. Magnesium carbonate acts by, so option A, forming magnesium chloride which induces osmotic laxation. Next is the protective and adsorbent. So example of the compound bismuth subcarbonate, chemical formula this one. So you read it this one because they are asking the MCQs. So bismuth subcarbonate molecular formula, and it is act as a protective agent and adsorbent. Protecting means protective coating over mucosal surface and prevent irritation by acids and toxins and digestive enzymes. So adsorbent means physically absorb toxins and gases and irritant substances on the surfaces. So reduce diarrhea by binding harmful material in the GI tract. Bismuth salts are widely used because they combine protective, adsorbent, and antiseptic action also it has. And also has one more action, astringent action also. Astringent. So bismuth subcarbonate is mainly classified as which type of gastrointestinal agent? So option B, protective and adsorbent. Next is the protective and adsorbent kaolin. So kaolin, light and heavy kaolins are there. So it is a kaolin is hydrated aluminum silicate. So nature and density, absorption and applications, you read it by taking this slide as a screenshot. And test for purity is very important. It is used absorption power and shaking the sample with methylene blue. So in order to do the test for purity, to check the absorption power. So by shaking the sample with methylene blue, it's very important. Test for purity aluminum hydroxide gel, acid neutralizing test for this kaolin. It's a absorption power. The molecular formula of kaolin. So option B, really. Which property makes light kaolin suitable for use as an internal gastrointestinal adsorbent? So option C, fine particle size with high absorption. Heavy kaolin is preferred for external applications mainly because it, so option B, is a coarse and possesses higher density. Next is the silicone polymer. So silicone polymers, it is type of adsorbent and protective, commonly called silicones, are synthetic polymers containing repeating CIOCI, siloxane, linkage with organic side chain, usually methyl group. So general structure, so this is a general structure where R is a methyl group, it's most pharmaceutical silicones. So this used for the antifoaming agent, GI anti-flatulence, topical protectant, and lubricant and emollients. And silicone polymer, there are examples dimethicone and simethicone. And it is dimethicone is a polydimethyl siloxane. It's a linear silicone polymer used in pharmaceuticals and cosmetics. So simethicone means activated dimethicone is called simethicone. It is an anti-flatulent agent consisting of dimethicone activated with finely divided silica to enhance antifoaming activity. So simethicone is a mixture of dimethicone and finally divided silica, and it is used as antiflatulent, topical skin protectant, emollient in creams and ointments. And simethicone is used as a flatulence, bloating, and dyspepsia. It's used with antacid like aluminum hydroxide and magnesium hydroxide, and is pediatric colic pain relief. It's used as a mainly pediatric colic pain relief. Silicone polymer used as a gastrointestinal agent are characterized by the presence of which repeating linkage? So option B is answer. Which of the following is the gastrointestinal use of silicone polymer? So option B, antifoaming and antiflatulent action. Dimethicone used in pharmaceuticals preparations is chemically classified as, so option B, polydimethyl siloxane. Simethicone differs from dimethicone because simethicone, option C, containing finely divided silica. Simethicone is commonly used in combination with which of the following agents? So option C, aluminum hydroxide and magnesium hydroxide. The primary mechanism by which dimethicone and simethicone relieve flatulence is by So option C, reducing surface tension of gas bubbles. This is a very important mechanism. How to reducing the flatulence. So flatulence means producing the uh, gases. So it is a relieving the flatulence by reducing surface tension of gas bubbles, so that it will act as a anti-flatulence agent. Antacids are the best defined as the agent that. So answer in the comment box. So join in our WhatsApp community. You will get number of uh, hands-out material. Thank you. Like, subscribe and share.